Today I'm going to talk to you about AI, and I'm sorry, I know it's boring for a lot of you to hear another talk about AI. I think what I'm trying to make a difference is that we've been actually trying to put this into production now for a year and a half, so it's less of the fluff and more of the annoying things. It's been going crazy, of course. With that course, OpenAI is just keep changing. I had this added yesterday. Another thing happened. It's like every time I need to rewrite my slides. But it's a fun thing. I get less bored than I used to be in that way. This was a situation a year and a half ago. It might be where you're at right now. Everybody wanted to have AI in the product, marketing, and then engineering had to build this. That was the situation I was in. We didn't know exactly what to expect, how this was working. We're all learning in our industry how this actually goes. We're learning every day how this is supposed to happen. Distinction, I'm not going to talk about ML ops and AI ops. I would categorize them into predictive things. They've been there before GenAI, so I'm particularly going to the GenAI things like LLMs and such. So just that distinction. All are interesting, but I have to limit it, and I have 100 slides already on the other topic. So, who am I? Most people know me from my DevOps work. As I told, I got a little bit bored after 15 years supporting this, and GenAI just reignited me as something new in the industry as such. Try to be the independent voice. I think a lot of people are here. I do my day job as a VP engineering, trying to level up engineering in a good way, and this is part of the journey also of that company that I was doing. Just a small summary. We are doing the obvious things, summaries, more intelligent search, but we're also doing things like people, when they upload like PDFs and marketing material, that we auto-generate like quizzes and testing to kind of level up marketing people there as well. So it's a little bit of a variety. We're not doing anything exceptional there as such. So the talk is going to be kind of structured as, first we're going to build the application, and we're discussing the pipeline. Once it's in production, we're operating it, and then once we have the first app, business as usual, we're scaling this out to multiple teams as such. First part, build, and you will see kind of those pieces come back. I assume everybody knows what a prompt is, a model data API orchestration that glues that all together. Maybe you don't know, but by the end you will know. So prompt engineering, a phrase you've come across. I assume everybody has, in some form, has used ChatGPT. The text you put in there is the prompt. One of the learnings in the beginning was it is never one prompt, right? It's like complicated, like zero shot, multi-shot. It goes going, and it's never just one prompt. It's like a continuous sequence of prompts, so latency goes up, like response, reply, all that stuff. It gets crazy to get better results. There's a lot of strategy, chain of thought, tree of thought, again, a field on its own. And then you get the results, but then you want to get the results back in a format you want. You want to bring in XML, but lo and behold, you ask it for XML or JSON, and it's not always correct. So you have to do the rerun. You're forcing this. And then if you want to be picky, like your schema of your API calls, you have to put that in there as well. Is the string actually a string? Is it really a number? And is it not the number in text? So there's a lot of retries. And this was one of the lessons first. Like, it looks simple, but when you actually want to make it reliable, you have to go through a lot of these hoops. The lower things are getting abstracted by some platforms. They do the retry under the hood. You now have options by saying, hey, I want this in JSON. So they're all kind of abstracting this away from you. This whole sequence is called a completion as such. No. My clicker decided not to continue, so I'll do it manually. Computers. So this actually brings a narrative. Like, flow is everywhere. It's not just in Agile. It's not just in processes. You actually see this now happening, a prompt. A sequence on prompt, it's like a flow. First you do a prompt, then you do some processing, then you go on to the next. So, Several people are starting now to talk about flow engineering in that way. Obviously confusing because flow is everywhere as a term, but it's an interesting keyword to look for things. So we learned it the hard way, putting this all together, response times, retries. But overall, the results were not that bad, but we also learned that especially in the beginning, when we had to change a lot of the models, all the prompts, we had to redo them. So that I'll come back to that, but it is like if it worked for version 1 of the model and you change the model, you just have to rewrite all your prompts. So it's not that static as the code will just work as we intended there. And one has been trained on JSON, the other one was changed on XML. So lots of refactoring happening there. So speaking of models, at that time, we were working with mostly AWS because we were an AWS shop, and that was easy. It's a tick on the bill, but they weren't ready compared to OpenAI. So they made us jump to all the models and learnings they had for us to get a better result. I think now we're at a point where they have like Claude, which is kind of on par with OpenAI. So that journey was a lot of changing, but it's settling down, it seems, right now. But still the industry, obviously, every day there is a new model, there is an improvement. So that sequence will kind of never stop as such. You can also go with open source models. You'll find them on Hugging Face. Very convenient, especially in the beginning when there were no SaaS solutions. We had to run our own models. As such, and these are also the ones you will likely be able to run on your laptop that was mentioned before. Then you look at all these models, like which one do I pick? Like what? Do I pick the latest? And there's like this inflation of, the context length, which is the length of the prompt you can actually put in the question you have. There's a limitation on there. So you start like with early on, it was 32K, and then all of a sudden, Google came out with like 1 million tokens you could put in. So that also kind of changes the dynamic of how much you can actually put in a prompt in there. But there's an interesting aspect is LLMs mimic in a way what humans do. So how do we read text? We look at the top, we skim through, and then we look at the bottom. So even with bigger context lengths or bigger things you could paste in, the LLM tends to forget what you put in the middle. So even if that big model, the results were not that good that you would expect. This is something they've been now actively working on, but it's something we learned, and you would want to think like, take the biggest Chinese model, but it was not always an improvement, and they're also more costly. The other thing that is like those shiny things to select on, how many parameters, so the matrices, the kind of the model bigness, you would think like the bigger model will give a better result. But it's actually not the case. It is how well they are trained. It has not always to do with how much kind of parameters you can look at. So again, it's like a trial and error, a little bit like your prompt. You have to try what your model actually will look like. And like I'm saying, now the people who build models, they're much more aware of not overtraining, not creating too big of a model, so that it fits in the memory. So there's a lot more optimization happening right now than it used to be in the beginning. But you got to start somewhere, so don't let this paralyze you. Just pick one and learn from there. And then there's the price. The bigger the context window, the bigger the number of parameters, the more expensive it is likely to be, the more capabilities. So you gotta, much like you were running service, you have to compare what makes sense in your case on the pricing. Is it a fixed price? Is it a per token price there as well? And another easy way for you to test this, there's playgrounds who allow you to take the same prompt and actually try this on multiple models. So you kind of have this overview, is it better here? Is it better there? To see the results. Obviously, there's specialized hardware. If you want to run your own LLM, there's something for everything to buy this. But this is one of the choices you have to make because companies are not used to handling GPUs, but for this they need GPUs. So there's this discussion, what should we do? Generic GPUs, optimized GPUs. So that was another discussion that was happening. And then when you're running this, open source versus closed source, I mentioned you go on Hugging Face to maybe take one, but what is the quality? And when we started, the quality was definitely like a big difference. Right now, this is kind of like a leaderboard, and you see GPT-4 on the top, Claude going down, and then the one before the button is Mixtral from a company Mistral, which is open source, but it's getting pretty much on par with the quality of a GPT-4. Of course, now GPT-5 will come, and then they'll have to catch up, but it's just to show you that it is possible to get a good quality model in open source right now. And one of the ways is that these models tend to be big, and there's a technology called quantization, which is when I have a 32 billion parameter model, I can reduce this. It will take trade-offs in how big it is, but think of it like shrinking the dimensions. Then I can run this on my own laptop. So obviously, the bigger model will have those kind of better results, but the quantization is what allows you to shrink one of those big models to something that can run on your laptop or even now on your phone in that way. So that's kind of the technique. And this person, the bloke, is the one that, like, if there's a model coming out, he builds like one of those. So he's an interesting person to kind of find models to play around with. So these are two solutions, just a reference of making it easy to run LLMs on your laptop. Ollama and LM Studio. It's just an interface. Which model do you want to run? Download, run, chat with the model. So that easy. No like install, pip install, all that stuff. It's just that easy right now. But models are humans, and there's gender bias. So you have to be aware of what you're putting out to your customer, that you are addressing these, and sometimes looking at the model, you want to know what it is trained on. For gender bias is one, racial bias another. So be aware if you are just doing the freedom for the end users, what they're asking for. We limited most of our use cases to be very specific and very constrained on what we're returning. But this could be an issue if you just make it too open, what people can ask for. Now, it might surprise you that we have all those cookies on the internet and robots.txt, but there was no equivalent for LLMs spidering the internet. After a certain pressure, OpenAI came out with something that was opting out of AI training. So it's similar to a robots.txt, but obviously they made it a little bit different just to make sure that whatever you put on your website is not in there. So that while we were learning on the models, it is something we put on our website just to make sure that what we didn't want indexed, that there was like a separation in there. It's also going to be one of those things that your customers will be asking for that. And then if you're familiar with SBOMs, think of it like a bill of material, what goes into software. This is similar for data, what went into your LLM. And on Hugging Face, they are called model cards. And this is how they explain how the model was created, what data went into the model. So not everybody does that, and obviously the SaaS providers will not give that away that clearly, but it's a similar trend as software SBOMs for data provenance there as well. Now, I want to mention this project. All the LLMs are somewhere in the big vendors. This is a project that is working on getting LLM contributions from the community. So they're trying to source in to build an LLM by the community, by content by the community. It's similar to a Wikipedia, but kind of like what is allowed to go into the model as a more neutral effort. So cool thing to check out there. So we learned this was nothing to do with ML ops. We did not have to train a model. We just used this. At that time, size provider was not good, but now they are. Run your own, run it through a similar interface. And I think the most important reasoning was when you pick a model, you check the provenance, it's doing what you want. We look at the cost in a way that it's like a bronze, silver, and gold model. So depending on the use case, you might be okay with a cheaper model that's slower, that is maybe not that good results. And sometimes you need a real-time perfect thing. So we kind of started thinking in use cases what kind of model we wanted to apply. So it's not like one model that we use for all our use cases, because that's also a conception initially. A lot of people think like, just pick one, that's the easiest, but you'll have to make a variety of models that you'll be running that way, even for LLMs there. Now, we got the prompt, we got a model, but how do we bring our own data into this? That's then the next question. And think of this like you going on ChatGPT and pasting your own bits and pieces into the prompt. Now, there is a concept called retrieval augmented generation, which actually does that for you. It retrieves information from your databases, from your file servers, and chunks them up. And then when you do a prompt, it will do a similar search to your data sources, and the relevant pieces it will actually put in the prompt. And that makes it like a better prompt to send off. It avoids that you have to train your data, you have to leak your data, and it gives a lot of flexibility of making this more tailored to your use case or to your company information as such. I'm going to skip that one. To finish this off, one of the benefits here is that because you're not putting things in the model, you are able to do access control. So only the things that somebody is allowed to search and see will actually go into the query, whereas it would be trained into model, everybody would have access to that information. So it's a very flexible thing to do that. So some people have built this internally, and that was the state a year ago. Now every SaaS and cloud provider will have you as an API. So we've done all the journey, and it's like, shit, now we can just move it to an existing service done. But we learned a lot on what is the right structure for the prompt, what is a good query, and we often also give feedback to kind of these tools. It's like, hey, this is not good. We want this more flexibility. But this is a constant, as we were so early in the journey, that you build it, you do it yourself, and then becomes commodity. So it's kind of like a cost that has to go. Same thing with fine-tuning or like making a specific model. It will become a commodity too. So we had the RAG and a customer typing in, I want a certain document. It would put in the search. We learned that customers need to get used to not entering keywords, but entering a question. Because they're so trained by Google that everything just by putting keywords gives that thing. But the LLMs do not respond well to keywords. So what we did is when a user enters a keyword-based query, we check whether it's a key-based or actually a question. And then we route it differently. If it's a keyword-based search, under the hood, we take the keywords and we formulate the question, and then we send it to an LLM. Because if we just send the keywords, it would not get a good result. So there's like a little getting used to from customers, and for them, they don't care whether it's a keyword or a question. They just want to have the search, and they will complain to you if it doesn't give the result they want. But so that required a little bit more trickery under the hood for us. So access control with RAG was a kind of solved thing. our company has like a lot of PDFs, Word documents, so all of a sudden that became gold that we had to parse all the data from. And for our cases, I know a lot of people talk about fine-tuning the LLMs, but we've so far have not have to do this. It saves us a lot of hassle, and RAG is our go-to pattern right now to expose that information. There is actually a test I often do when I go into a company and ask them, what are you doing with GenAI? When they are talking about training the model, the companies run, or like GenAI projects are run by the data science people. If they talk about RAG, I know they're run by the engineering. So it's an easy thing, but it's often quite true. So right now, we're exploring more on agents, and this will have a deeper kind of form of integrations, also into workflows. But we have a few hassles with that, is that we need a memory of things people have done. So the data is usually available somewhere in the database. The model and the prompt are things you can develop. But the memory is something that's usually only available in the data lake. It's not supposed to be consumed real time on the activities a user does. So that's what we're working on right now, is like all the activity that is data lake and reporting now has to become more real-time available for us to build actually agents who have a memory of things that have been done. So that's our current struggle to make that happen. So yeah, we explored also GPTs in that same context. We're a sales company, sales and marketing. Obviously, everybody talks about having an assistant. We're not there yet. We still build it into the use cases itself and specific things like generate like a test, a quiz, but not just have a co-pilot there. But everybody seems to be asking for kind of that. So yeah, this is the model they think in. They have like a bunch of AI assistants doing similar things. When they are having the marketing, they want to have their marketing material reviewed by a legal advisor, the developer, and other things. So this is kind of the mental framework people have. But anyway, it's not the first thing we wanted to build. We just wanted to make AI help specific use cases instead of going for the more generic AI assistant. But we know kind of AI's agents are coming. So the other thing that we learned is with the prompt, you start thinking differently about the code. And especially with our first things on agents, is that you don't instruct the thing how to do certain things. You express more what you want it to do. And then you see certain magic of reasoning happening by the agents. And it feels very uneasy for our engineers and developers to kind of stop building the thing ourselves, but kind of ask the higher level, express more of the why, and then kind of have the agents build this. So it's just an interesting observation how we maybe are ready for other abstraction in that world. So yeah, context, content, and events, it's working, but we're continuing that. So the final layer that glues it all together is often called an orchestration layer. So it takes the data, has loader, chunkers, fetchers of all the data sources. Then there's a prompt, but not the prompt. It has templating. It has like a structure generation. So all these things are built in. The API and the routing, for example, is it a keyword, is it not a keyword, and then the memory. So LangChain, Llama, Index, Semantic Kernel, if you're on the Microsoft world, they're all the kind of those frameworks who, like a middleware that glues them all together so you don't have to do the heavy lifting. There's been a bit of pushback from the engineers on using a framework because the frameworks changed so fast, they could not keep up with their documentation. And they were very dissatisfied as the developers, and they said, I don't need all these abstraction layers. I'm just going to use the API directly there. But I think it's maybe temporary. because once you have middleware, there's going to be tooling in the middleware, and we're just going to expand. But this might be something that comes up. Should we use a framework? Yes and no. But I think we're now, after a year and a half, the frameworks are like stabilizing in that way. So those are a few there as well, mostly around Python for the obvious reasons from the data science, but there are others who have like Java, JavaScript interfaces, but it's still mainly Python-centric, which is also another thing. Like if your company is not Python-centric, all of a sudden there's a new programming language with no kind of knowledge, no set of practices. So it's also a weird thing to kind of adopt this because we have to, and at the speed that usually a new thing is not maybe introduced in a company. So I mentioned this before that we learned a lot about prompt engineering, and the prompt engineering is actually the most artisanal part of the whole thing. Change the model, add one semicolon in the prompt, different behavior, add an enter, a line feed, different results. So it's very finicky. It's not something you want to do. So when you're switching a lot of the models all the time, this is a very costly thing because every time it is reworking. Now, you see the industry coming up with better ways of dealing with that, and one is, think of it as a transpiler from one prompt to another prompt, and they understand what actually the model wants. Is it XML it wants? Is it JSON it wants? So they're starting to have like an optimizer in between for you not to always have to rewrite your prompts. So Anthropic has this in like a workbench UI, and DSPY is actually an alternative framework to LangChain and so on, but they have this built in that you don't have to know the inner details of the model that you're using. It just will optimize your prompt for the model that it knows it's select. But this is a couple of months old, but I think it's a nice thing that we're getting better at dealing with these like constant refactorings. Yeah, I think I talked about most of that. There's much as in kind of infrastructure as code, there's a little bit of a discussion going on. Should we do this as code, or should we do this as YAML? So that same discussion is also going on as well, because a lot of it is like a piping, like I showed the flow, like one thing after the other thing after the other thing. So that sequence could also be described as just a format or a config file instead of having this done through code. So this is one where you actually take your code, you save it to a JSON, and that is actually more determined. You have the equivalent, people trying to do the model, running a model similar to a Docker file where you set like, this is the base model, this is the context window, this is how I want this to behave. So you see like a variety of things people are trying to make it like what they really want. So there's not one way of doing this. Again, fine tuning, also declare it. So I rushed actually through a lot of the different pieces, but I hope this gives you an idea, and I know it's recorded so you can watch it again. But it's more about giving you jump points and kind of awareness versus going into all the things very deeply. So yeah, next part is we have the whole app, and there's this mystifying thing, how do you get this thing to production? But a prompt is just text. It fits into a GitHub repository. There's nothing magically to this, right? But when you would just think about like putting your prompts and deploying your prompts only, you know when the model changes, there is a friction. So what you do, or at least what we do, is when there's a change in the API, the data interfacing, or the model, whenever there's a change on any of those, we do a new deploy. So we treat it as one release, one binary, where as some people try to do it with separately, they deploy the model separately, and then do the data. You could obviously use like feature flags where you can like slice this in, but often you need a combination of all the things together to actually understand the version that you're deploying at once. So this brings, you put that into your CI/CD pipeline. The most annoying part is that sometimes you need like GPUs, which you don't have, so you get into the hassle of asking those in there as well. But besides that, it's running in a container. It can run in a serverless. It is not anything special from a code perspective to run that in production like that. The interesting part is testing. And it's one of the things when I go to a meetup and there's a startup, it's like, oh, we're doing all this GenAI. It's like, okay, so how are you doing your testing? Well, we'll get to that later. So obviously, it's still the same thing. People don't like to write tests. And in this case, I can understand them because what we are testing here is not deterministic. And it's weird for a developer to, even if they are writing tests, of writing something that you cannot verify immediately. So you'll see this happening. They do a deploy, another deploy, and then the product owner gets annoyed that there's a new playtest or something. And so then they start thinking of testing more and more, or when things go wrong in production. So similar to any application happening there. So the way that I categorize this is the test or the text evaluation type. If I can do an exact testing, like this text is supposed to be more than 20 characters when I ask it for an answer. That's a pretty thing that I can do. That's the common thing. Pattern matching, I want this to have certain words in there. Okay, that's easy to write a test for that. But then, like, is this reply nice? So how do we test nice? So luckily, we have models that have been trained for specific qualities in text, like machine learning models, not large language models. And we can ask it about, is this text toxic? Is this text, what's the sentiment? Is this optimistic? So that's another way of bringing this into a test, but they're like a little bit slower than your exact test because you need to run this, and then people can't run this maybe on their laptop because models often need a GPU. So you get into this like friction, like where do you run the tests, and they skip the tests. Another thing is semantic distance. If I ask a question and I get a reply, how related are these? So I can check this. So this is semantic distance that gives me some feeling, but you understand, like sentiment and quality and semantic distance, it's like a valve, right? So it's like, is 80% enough? Good enough? Is it 70? So it becomes like fuzzy, more like fuzzy testing in a way. And then there's the other approach. You can combine, obviously, all approach, and it's called like ask an LLM. So this is called a pattern called LLM as a judge. So you have one LLM generating an answer, and then you ask another LLM, what do you think about this one? And this is basically your test. So, but it's a constant, like how do you solve things in the AI world? You add more AI to it, and then it becomes even more complicated. So, but, and then obviously as a last resort, you can ask a human to verify this and do some manual testing. But those are the two approaches. Well, not two, but the main new things are you use a model for specifics, or you use an LLM as a judge to do that. I haven't seen any other approaches, so if you know any, let me know. So kind of those things, but you can also do this for security and privacy. Tests, is this a prompt injection, yes or no, on a reply? Is it readable? So quality metrics. I'll skip through that one. So this is just an example of those quality metrics for a DevOps setting. So DevOps, I ask a question, what was my bill? But how do I know like the reply of an LLM is good? Yeah. So they actually test multiple DevOps tools, and they rank them through one of those LLM as a judge or model as a judge. So it's a cool project to look at if you're interested. So GPU access is actually one of the main problems, and testing is the other thing that a lot of the teams actually need to be aware of. All right, we're going to production. Yay! A new stack of things is coming up. So you think you know your runtime and your Docker, but obviously it didn't stop there. And a lot of people will think about, oh, I can monitor my metrics, how fast it goes, and so on. So those are the traditional metrics of monitoring of the quality of your things. But now there's things like cost that become more important, your tokens requests per second, but I would call this still like the traditional metrics in there. Time to first token is how long does a user have to wait. Those are like new kind of metrics. We have that on the network, but now we have the latency on the response time as well. So those are kind of throughput, new metrics that we're monitoring in production. And we also want to monitor our data quality. So I explained LLM as a judge, using a model as a helper for verification. We want to do the same thing continuously in production as well, because we don't know what end users are putting in the prompt. So we want to monitor that they're not doing strange things. And if you rely maybe on third parties like OpenAI, they change the model, all of a sudden your application starts behaving differently. So kind of those things requires kind of those continuous monitoring there as well. People have open telemetry, so now it's like open LLMetry. It's a service that does that for you. And the same thing with PII checks for the security folks, have this continuously monitored as an application as well. And this is an example of a model versus an LLM. They just say like, hey, you're an LLM, you should act as a security researcher. What do you think about this? Reply, is it good? So kind of those kind of tricks that you can do. It's not a solved problem, but it's people are trying to do this. So this is companies trying to make a product out of that to do this, verifying what goes in and out in production as a monitoring service there as well. And then you need to mask PII, nothing new, because there might be a lot of data going in, data going out there as well. And you start seeing this concept of a WAF, a web application firewall, but it's more like a data filtering firewall on what is supposed to go in and out from your prompts and what is the reply as an infrastructure there as well. There's caching, because if users are doing the query over and over again, this is another piece of infrastructure you want to put in there to save costs. And there are also kind of frameworks spinning up, like HelixML. Think of it like, what will be the Kubernetes equivalent for this new world? What software does it look like that I can take, like run anywhere in an organization, independent of a lot of stuff? So cool stuff happening. But much like the Kubernetes ecosystem, this is just growing and growing as something you need to be aware of, and it requires a different way of thinking than I think from the traditional application development. Traces, we all know API traces, but I explained to you like it's a flow. So if you want to see the results, so people are building like prompt tracers to go across calls. The quality evaluations. So if you know it's bad, you want to see what was the input, what was the output for debugging in production. So that's another set of things you want to put in. And then people start thinking like, well, maybe it requires its own kind of ops to deal with this, because we're getting infrastructure, we're getting a lot of pieces, so maybe there's something new coming up. There as well. A/B testing of prompts, you try one, there's a better result. So a lot of engineering practices we're reusing, like observability testing, but we need a little bit of free thinking on how this is actually working with the new technology there as well. Capturing user feedback. You might have wondered, like thumbs up, thumbs down. That's to actually understand, obviously, users like it, but it's very valuable for the people developing the prompts. Those are getting them as a test set of cases that people didn't like. So then they can put that in their evaluations to improve this. But thumbs ups, thumbs downs, it might be that the user just didn't like the answer, not that it was badly generated. Try again is a retry, so you know they weren't happy with the first one, so you can learn from that. If they copy it, it's another signal they might be interested in, so it's a more positive signal that they want to use it. And then, very interestingly, we capture all the responses, but we at one case, we put an editor in there. So we can actually see in the product what people were changing about the result. So this gives us a next level of feedback instead of just saying, we didn't like it. It's like, what did you not like? What were you still editing manually? So kind of finding that feedback, but capturing that feedback is actually a service on its own, right? So it's also a new thing when you set this up that you have to go. You can cobble this together, obviously, like it's a post and there's no magic to it. But managing this is quite some work there. And yeah, we often joke like we'll fix it in prod. Well, in this case, we're just learning in prod what end users are putting in this there as well. So final thing, business as usual. We got it up and running. It's going. My job was how do you spread this to engineers? They're all afraid about the AI. They think they need to be data scientists. I tell them this is all about integration. You don't have to worry. You don't have to know the math. You can just do this. This is an interesting research paper that they ask a lot of developers, are you scared about AI? A lot of people are saying this, but they also found that the companies who are mostly have a learning culture, obviously they're the easiest ones to adapt to this. So there's a relation to like how well you're dealing with your culture to how well you're dealing with like this AI skill threat. And then the other thing, our data scientists, they were used to being somewhere in the basement and seeing like signal in the noise and digging into a lot of data. All of a sudden, they were the star of the show. They needed to build application and production-ready things. So for them, it was like a huge shift of all of a sudden having to apply engineering practices and applications. So in the industry, that's sometimes talked about on a shift right. So we had shift left of going earlier in for security. But in this case, well, data is not just there. It needs to be used in production. So that's kind of the stretch where a lot of people are going for. This comes from this main article where you see somewhere the machine learning expert and then the full stack, and the concept of AI engineer is the one that like starts resonating a lot in the industry as the new breed. They understand AI, they understand coding, and they can deal with some of that stuff. Maybe it will be absorbed again into the full stack engineer. So that's kind of like the industry term that is coming out of that. So you do a lot of hackathons, you find people, you have them try, you make it as simple as possible to play with this, so they are not afraid and they kind of get an understanding that they can actually do this as such. You want to build an AI native product, so cloud native took us some time to understand what this means. We're in that phase. What does AI native mean in our applications there? And one of the things, maybe from my background, I started thinking about where does it fit into the organization? A lot of people start with a small change, a small group in the company, but then you want to like have multiple groups with that. And I think the closest pattern that matches that is that eventually the shared knowledge and the shared things will fit into a platform team. So the CloudOps, SecOps, developer experience data platform, there will be an AI platform team taking care of all the infrastructure that is shared, all the shared prompts maybe that you're using, the build pipelines for that, and they do also the enablement on learning and educating other teams in the company there as well. So I think making that platform enabling and then putting governance in place, you should not use model A or B, or make sure you have the filtering on and all those guardrails. I'm gonna go a bit faster because I'm over time. Right, let's go this. Sorry. I'll leave it at yes. So innovation tax, I mentioned this. It is pretty costly if you want to be first. everything you build right now is instant legacy. You know, it's going to move either to a service or there's going to be a new version of whatever framework, whatever tool, whatever model you've built. So there's a lot of cost involved, but you know, in our case, we had to. There was a lot of pressure, and it's definitely a race for all the others. And you have to make sure that you go deeper and deeper in the product and not just do it on the surface. Rethink your actually use case, your workflow at the core, and not just put some trinkets on there to make it better. And we're getting into a weird thing. These tools are starting to record your desktop and see what you're doing. Whole new set of privacy problems, obviously, but let's rub some more AI on there. AI is a teammate, so you're not just asking, it's always there. It has a cursor similar to Google Docs. It will see when you're hesitating. It will see when you need some help. It will just do it there. We're going to see weird things like a dynamically generated web that is part of hallucinations, and people are generating the pages as we go. Weird stuff coming up in there. And we're likely going to do our engineering work, and we're going to go over-engineer it with like prompt queue, prompt pipelines, prompt lake, I don't know what. That's just the nature of the beast. And if you want to have more learnings, you can find me on my YouTube channel or talk to me later today on this. So yeah, I'll leave you with this quote. And I think it's kind of true. Thank you very much.